Now let's look at Azure Firewall, how it helps with both segmentation and threat protection. Now, if you everybody has to be familiar with the firewall. The reason is anytime you need one network security device, like I can start up my small business and it'll work fine without any firewall until I realize I need it. And I'll realize very quickly if I have public IPs that I need a firewall. So firewall is in every architecture. Basically, firewall helps you filter out unwanted traffic from the internet, but it also can give that visibility and ability to centrally control all your flows. So Azure has Azure Firewall, which is a cloud-native firewall. So just to give that, so the background was where you need a firewall, typically central flows and ability to protect all your environments. Azure Firewall is a cloud-native firewall. Cloud-native meaning we saw the benefits before with private link, quick to deploy, less operational work. It has built-in high availability. You all, from your perspective, deploy a firewall, and it takes care of the scale and the redundancy and availability in underneath the hood. It can be deployed across zones to give that redundancy, and then integrates well with other services like DevOps, like monitoring. So the way to manage the firewall is pretty simple. So those are the benefits of cloud native. Firewall as a function, its use cases are helps with network and application traffic filtering. So it has built-in threat intelligence. Microsoft has Microsoft's threat intelligence that has visibility across all the traffic that Azure sees. And Azure sees a lot of traffic. It's a large public cloud. From that, it gets intelligence and it knows the malicious IPs and malicious FQDNs, which should not be talking to your environment, or your environment should not be talking to. So Azure Firewall has integrated with that Microsoft Threat Intelligence and can act on, once you configure it, act on blocking that unwanted traffic to your workloads. It supports network and network rules. So for example, I talked about spoke-to-spoke communication. So that's your east-west traffic, VM to internet communication, internet to VM communication. Now, all the environments go through the firewall. So there's one place where you can have the rules to block things that you don't want. Azure Firewall comes in 3 different SKUs. There is the basic SKU, and it differs based on the features and, more importantly, aligned to the customer segment. Basic SKU is for small and medium businesses where they need a firewall, but they don't have a very large environment that they maintain or they need it for, as well as they have the cost efficiency in mind. So basic SKU is specifically targeted to SMB segments with the same benefits of cloud native and most of the functionality that a firewall needs. Standard SKU is for enterprises, large environments where you need more throughput and more features. And then premium SKU is for very high sensitive, high security environments where you have sensitive workloads, you need more threat protection. So it has features like intrusion detection and prevention. And so each of these SKUs has a use case based on the features they provide. The throughput as well as the cost varies accordingly. So just to get a glimpse into the journey of Azure Firewall Standard went GA in 2018. It is the first cloud-native firewall. Before that, there wasn't a cloud-native firewall. But once it is there, we really got a lot of interest. And as you see here, the journey, all of the requests come from the customer, right? Feedback comes from the customer, and we add features. So threat intelligence was integrated in 2019. firewall manager, to be able to manage multiple firewalls came in 2020 and so on. And now we have basic SKU to also address the needs of small and medium businesses. So it's clearly gotten a lot of love and growing in features very fast. So I did talk about the benefits, but just to walk through some, and actually I have a demo too, so we will walk through that through the demo as well. But there is network filtering that we are familiar with, where you give IP address to IP address, right? Source destination, similar to what we saw in NSGs. That's the network rules. Any traditional firewall has it. And that's how you apply it from a particular IP address range to a particular IP address range. But in addition, we have application traffic filtering. So in this case, you want to say something like, I want to allow specific URLs. So my VM can go to Microsoft.com, to Bing.com, but maybe I don't want it to go to social networks. So ability to give that URL level filtering is what application traffic does, and Azure Firewall has those features. I did talk about the rest, and we are going, there you go. So firewall use cases, how do you deploy this firewall? So firewall lives in a virtual network. So it is for your protecting your IaaS workloads. It can be deployed, typically deployed in a hub network where you have multiple VNets connected to it. So now if you want all traffic going to the internet goes through the hub VNet, and the firewall being in the hub VNet, you can route all the traffic through this firewall. You need a route in the spoke VNets to be able to allow this communication, but that's it. There is one firewall taking care of all your traffic across many spokes. If you don't have a hub VNet, then it is in a regular VNet. So just imagine if you have 10 VNets, you need 10 firewalls. So hub and spoke is the architecture to go to. Hub typically is for the centralized services. If you look at on-premises, we had all this access and distribution layer, and then starts the core where you have firewall, load balancers. Similarly, the hub is that environment where you put the firewall in. You can control spoke-to-spoke traffic, and you can control north-south traffic. Now, we do have something called virtual WAN. If you're familiar with it, virtual WAN is a managed hub. So it's similar to hub and spoke in some way, but the hub part is managed. And the main use cases, you can have multiple customer branches, on-prem branches connected to it. The main use case is the scale with the amount of branches that the customer has. These can be very small branches, and to simplify the connectivity and configuration and operations for this. So if you want to secure that virtual WAN hub, Azure Firewall can be deployed in that hub, and then traffic to on-premise to all the branches to VNets and back and to the internet is configured. But in that virtual WAN hub, you're able to deploy the firewall. It's a bit of a different approach. It's a bit of a managed approach, but that's something it's easy. It also integrates with third-party firewalls. In a virtual WAN hub, you can have a third-party firewall for internet traffic. Then you can have hub plus the firewall configured such that the rest of the traffic goes through the firewall, and then internet traffic goes through the NVA. So just to break down the feature sets of each of the firewalls, Azure Firewall Basic is a smaller firewall throughput-wise. It goes up to 250 meg, but it has all the benefits of cloud native. It has built-in high availability, and you can access it with other resources like the firewall does. It does have threat intelligence, and threat intelligence is a very, very good feature where you just enable threat intelligence and you get protection from all the very well-known malicious IPs, right? With Azure Firewall Basic, you do get alerts on this feature. So you can configure login to log analytics storage, whichever way, but that traffic is not blocked. You have to look at the logs And then you see the malicious IPs if they are being, so it identifies in the log, right? This log is coming from threat intelligence, and these are the IPs it shouldn't be. So you can go ahead and add rules to block that traffic. And then rest of the features are there. I think the biggest thing is the throughput. It is 250 meg, where you know that you don't need anything more than that, and that's where the use case is. Azure Firewall Standard, everything of Azure Firewall Basic, but in addition, the throughput is up to 30 gig. And that's the scale of cloud native firewall. You can go very high in scale without having to do anything, right? It happens under the hood. So Azure Firewall Standard can go up to 30 gig. Azure Firewall Premium can go up to 100 gigabits per second. And then Azure Firewall Standard has the same centralized policy features, but it has some more features. We will walk through the portal and go through some of this. But the biggest difference is the bandwidth. And then Azure Firewall Premium is where you get the IDPS, TLS inspection, URL filtering, and other features. This is where it is a lot more on the protection side than centralized flow side. So IDPS is Azure Firewall. Azure Firewall Premium is for that extra level of protection from the many threats that are out there. Azure Firewall Premium goes up to 100 gigabits per second. And of course, keep in mind that Azure Firewall does have certifications. From if you go to our website, there's a very long list of certifications. So be it for finance industry, we have PCI DSS, SOC compliance certifications. For healthcare, there is HIPAA compliance. There is for gov environments, there is compliance. So typically, firewall is also used for compliance requirements. And especially for these environments that I mentioned, you need a lot of these features. So based on your requirement, go to our firewalls certifications page. There's a very long list, and you can find the certifications that firewall meets. It should meet most of the certifications, but make sure over there. And that's the beauty of that this firewall provides compliance, so meets your compliance requirements. So comparison of features, right? So all three of the firewalls have the basic L3 to L7 filtering, same performance reliability. Throughput differs, like we talked about, but the same ease of management. Big feature of cloud native is ease of management. Where it differs is those advanced features. For example, basic firewall does not have web content filtering, and DNS proxy. Actually, Firewall Standard and Premium can act as a DNS proxy for your environments. And then when it comes to TLS inspection, IDPS URL filtering, that's all for the private premium. So really, the features are really broken down based on industry requirements and throughput requirements. So when I talk about the different things that the firewall does, what is the rule processing logic, right? Which rules get executed first? So whenever you have threat intelligence enabled, that's the first thing that will get executed. So if I have threat intelligence deployed in deny mode, that traffic will be dropped before executing anything else, and you want it that way. Now, firewall is also used, once you put a firewall, nothing can go through it unless you allow it, right? So you do need destination NAT for all inbound traffic. Those destination NAT is what gets executed next. For outbound traffic, of course, keep in mind, outbound traffic to the internet is always NATed. We have ability to, east-west is not NATed, but we have ability to define ranges that cannot be NATed for east-west. And then it is, so NAT rules translates to the actual IPs that you want to reach in your environment, and then the network rules kick in. And once the network rules are executed, and if the traffic is allowed, then the application rules get checked, and then if the traffic is allowed, it is allowed. By default, there is a deny. So if no rules match, the traffic is dropped. And that's the important thing to keep in mind. Inbound as well as outbound with firewall, default deny. So other thing to keep in mind is don't put a deny rule on network rules, because if you put a explicit deny rule, then the traffic is dropped because it matches that rule and it won't check the application rules. So we have a way to do policy analytics in firewall. So you can add rules as a regular rules, but there is a concept of firewall policy. I'll be talking more when I talk about premium firewall, but basically you have the ability to go through the policy rules and understand. If you have worked on firewalls, you know how crazy the rules get, how out of control the rules can get. And that's where the policy analytics gives you those insights, tells you which rules are heavily used, which rules are not used, and you can kind of see any duplicate rules, remove those, but it also gives you recommendation how to change a rule. So it's very helpful in operational environments. And rules can get crazy in any environment, because we are managing multiple applications, multiple scenarios, and they are constantly being added, right? These new applications are constantly being added. So just to keep the troubleshooting easy, policy analytics helps us out there. We have Azure Sentinel, which is our cloud native CM. And Azure Firewall has good integration with this. A very big feature of managing threats is visibility, right? It goes without saying. You have to have logging enabled. You want visibility into your metrics. What Azure Sentinel does is it gives you one place. It's like a CM, and you could take all these logs to your third party CM too. But what it gives is one place to view all the logs and then correlate the logs and then get insights from there. So Azure Firewall has a workbook that you can, as you see on the right side, it's a dashboard. It's a visual dashboard that you can see the environment at a glance. And then on top of it, there's an Azure Firewall solution that's integrated into Sentinel with its built-in analytics. And then it also is a source solution, meaning you have ability to have automation to the incidents or alerts that come up. So Azure Firewall does have a solution that integrates with Sentinel to make it easy to respond to threats. So remember, first thing, visibility. There is no environment that you just put these solutions and you're done. You want to know why something was blocked. You want to know what traffic is allowed, etc. And then the other piece is to respond to it, right? So how to make it easy to get those insights and then respond to it. And we'll see this across all the solutions that we talk about today. As I talked about Microsoft solution, but you see here the built-in threat detection. These are the things it will alert on. Like if somebody's doing a port scan on your network, it's going to capture that traffic and trigger an alert, or you can trigger an alert, but create an incident. And then we have something called hunting queries in Azure Sentinel that enables you to get insights from the logs. So it'll look for something like first time a source IP connects to a destination port. Let's say a VM is running, your application is running for a long time, for many months, and then this is the first time a source IP connected, then you want to know, right? If many source IPs connect for the first time after many months, you want to know, you want to understand. So that kind of abnormality, it will highlight. And then there is that piece of automatic response that we talked about. I am going to, sorry, I will just talk about it here. So what kind of automatic response does the Azure Firewall solution have in Azure Sentinel, right? So we talked about that port scan, port sweep kind of incidents. If that incident occurs, Sentinel has a way of creating a playbook. And then what kind of things you can do is here, right? So if I see an IP doing port scan, add it to my IP group, and in my rules or IP group or IP list, in my rules, I will have a rules for this IP group, deny traffic, right? And then it may be empty IP group. IP group is a collection of IPs, by the way, in the source or destination. And then this can be empty, but as you see these incidents happen, like somebody's doing port scanning, that IP can be added to this IP group, and now firewall already has a rule to deny that traffic. So as soon as we detect somebody is doing a port scan, that their traffic is dropped by the firewall, because we just use CM to automate the response and update the firewall rules. And similarly, you can add IP to a threat intel allow list or block list. Okay, so let's look at Azure Firewall Manager. From Azure Firewall Manager perspective, so when you have Azure firewalls, you can have multiple environments running and end up with a lot of firewalls in your network. But we wanted a single pane of glass. So how do we achieve that, right? So that's where the complexity comes in from a security team's perspective, from InfoSec's perspective, even from administration perspective. You want complete visibility across all your networks. And let's say I have dev test environment, prod environment, I have different organizations. So at the end of it, there are like maybe 20, 30 such environments. And now I have to go on each firewall and go manage and look at the rules. How do I simplify that? So that's the first thing, complete visibility from one place, right? The other thing is I have so many policies across all these environments. Now I'm seeing this offending traffic, and I established this is not good traffic. Now I go to the firewall, add rules to update it, go to another firewall, add rules to update it. How can I make sure I take this set of rules and go apply to all my firewalls? And that's what I want to try to achieve. That's another use case where we want simplified rule management. And then compliance with zero trust. Again, with those policies, I'm seeing offending traffic. I want to, with one click, apply to all the firewalls. That's how I achieve zero trust, right? And that's what I want to do. So automatic, quickly secure. I won't say automatic. Automatic is with CM, but I want to quickly secure. I don't want to wait for an hour to reach all 20 firewalls, as an example. It helps me respond to threats very quickly. So for all these use cases, basically, I want a single pane of glass to monitor and protect my environment. And that's where Azure Firewall Manager comes in. It gives you that single pane of glass. So basically, it is where you can view your entire VNet environments. You can see what firewalls you have deployed. You can see what environments are protected by firewall, and you can create something called Azure Firewall Policy, which is one place you add the rules, and you can attach it to multiple firewalls. So a lot of things that you can do from Azure Firewall versus having to go to each and every firewall. There are more features we will talk as we go through the day that you can do DDoS management, WAF management as well through it. And this is how it looks. I have multiple environments below. Each of them have a firewall, but with that firewall manager, I'm able to monitor and manage these environments. That's it. I'm going to move forward. So we also have virtual WAN. Like I said, you can have third-party environments here. So this is just saying what I already covered, that you can have Azure Firewall in here, but then route traffic to all your environments through the Azure Firewall, and then have integration with the third-party solutions. There are some third-party solutions that are listed here that you have integration with, and that list grows. So when you look at pricing, as you see here, pricing differs by the SKU. But more importantly, there is a fixed cost and there is a variable cost. So when you deploy a firewall, there is a cost per hour of firewall deployment. so per hour of when the firewall is running, and then there is a variable cost on how much traffic is processed by the firewall. And with the fixed cost, keep in mind you're deploying a firewall, but underneath the hood, it's taking care of that scale and management. So a lot of times I get asked the question, how does Azure Firewall compare to NVAs or third-party firewalls, right? So in general comparison, Azure Firewall is cloud native. I think we covered a lot about what a cloud native firewall advantages are. You don't have to have VMs management, licensing, updating the software, load balancing it both inbound and outbound, and all that is taken care of for you with cloud native. The features, we looked at all the features that are there. If you go to Azure Firewall Premium, that's all the security features there. Throughput, the other big benefit is cloud scale. You can go up to 30 gigabits per second on standard firewall, but also up to 100 gigabits with the premium firewall. So there is a cloud scale, right? Everything is managed for you, but it gives you that cloud scale. So whenever you compare the pricing also, Azure Firewall will be significantly cheaper. Keep in mind, Azure Firewall also meets all the compliance requirements that you have. So just to keep in mind, if you're talking to your customers, they will ask you this question. Managing with Azure Firewall in Azure is always easy, like we saw with the previous private link, like we'll see with Firewall and other solutions. It's less operational, less management, and because it's less of both, there is less risk of errors. That's a very important thing, because when there is an error, when there is a misconfiguration, that's where the attack vulnerability increases. So those are the things that are big benefits with Azure Firewall. And then Firewall Manager by itself, Firewall Manager does not have a cost, but there is Azure Firewall cost, and then there is a policies cost. And that's how it is. There's a fixed cost for policies. And then if you're in the virtual hub, if you're using third-party integration, there is a cost for third-party integration. And for all the regulated industries, this is a requirement. So if you have a requirement of IDPS, you know what I'm talking about. And this doesn't have to be a small or big. If you have sensitive environments that you're working in, your compliance requirements need you to have inspection capabilities, and that's what Azure Firewall does. There are a few features here. Basically, whenever the traffic goes through the firewall, we want the ability to read into the packet and do all the detection and then do the prevention based on the signatures that are matched, right? So we will walk through each of this. Let me talk about TLS inspection first. So when the traffic, so with TLS inspection, you are enabling the firewall to inspect encrypted traffic, right? So typically when the firewall, so TLS inspection works outbound and east-west. For inbound, we have application gateway, more tuned to application traffic, and we will use application gateway combined with Azure Firewall to do the inspection. Let's see how it works. So what do I mean by inspection, right? When the packet traverses the firewall, and here I have an example of Azure Firewall Standard, I can see based on the source and the destination, I can also see the URL, but that's all I can see, www.contoso.com in this example. But when it is HTTPS traffic, that's all I can see. Everything else is encrypted. Much of the header and all of the body is encrypted. So the firewall does its best from what it sees, right? From here, it will say contoso.com. Are you allowed or denied? And based on that, make a decision and let the packet go through. But there is, while HTTPS is encryption, and we should have encryption, like we talked about end-to-end encryption, it doesn't always mean that it is secure packet, right? Nobody can sniff into it. But malicious attackers, they know to take advantage of it. Now they will put some byte sequences in it, hide some malware in it, and they know you're going to pass it through the firewall, so encrypted. So firewall cannot see it, doesn't know there is all this malware in it, goes to the server where it gets decrypted, and there is a breach. So how do we help the scenario, right? How do we make sure malware doesn't reach our environment? And that's the use case for TLS inspection. That's what TLS inspection does. Now let's take the scenario. On the left side, the client is sending an encrypted traffic to my server, or the VM is sending to a server contoso.com. In this case, the firewall says, oh, this is encrypted traffic. It knows to terminate the traffic on the firewall. That's what it's going to do, because now it can decrypt the traffic, and then it inspects the traffic and then sends the traffic to the destination. This way you make sure that there is no unwanted malware, etc. in the packet, right? And for this, the firewall needs a certificate. So you see the certificates that are there. Actually, this diagram shows it better. So here from the end user, your VM sends a packet, goes to the firewall decrypts it. Firewall needs an intermediary certificate here. So if you have your enterprise, CA, or PKI infrastructure, you create an intermediary certificate and put it on the firewall. So on the firewall, the certificate does not directly stay, right? So they put the certificate into Azure Key Vault and then link Azure Key Vault to the firewall. That way, your certificate is secure in the Key Vault. Azure Key Vault is a service just to secure all your certificates and secrets. But then with that certificate, actually the firewall will open the connection to the destination you were trying to go, complete that handshake with that destination, and open a new connection back to the end user who was trying to access it, and then respond with that intermediary certificate, establish the connection with that intermediate certificate that you have. If you have, actually here, no. So if you have, if for demo environments, we have an ability to create Azure Firewall root certificate you can use. It's only for demo environments, non-prod environments, not for production. So one thing to keep in mind, Azure Firewall works with outbound traffic from your VM going out and east-west traffic. So from your VM to one of your applications, it does not by itself do inbound communication, right? So when we talk about non-prod environments, just keep that in mind. The certificate used for non-prod is something that the Azure Firewall generates. It cannot be used for inbound traffic. So, but for inbound traffic, what do we do? So Azure Application Gateway, and then HTTPS is, mainly for application traffic. Azure Application Gateway has the ability to terminate the traffic because that's what it does. It's the layer 7 load balancer. And then it will have its own web application firewall. And then it will create a new connection to the backend. So for that, we route the backend traffic to the Azure Firewall Premium. Premium has this functionality, and then route it to the backend server from the firewall. So basically what we did is we inserted firewall in the middle. And this traffic is east-west because the backend IP of the application gateway is a private IP, and we are talking to the VM in our environment, which is private IP. Now it is east-west. And Firewall Premium can now do TLS inspection on that traffic. So you can send encrypted traffic to the backend to remember end-to-end encryption, and then the firewall can do TLS inspection. The whole point of TLS inspection is to decrypt that traffic and inspect it using IDPS. Inspect it for threat intel and web filtering, etc. So that's where we need TLS inspection. That's how it helps. So really, with this architecture, you're able to do outbound, east-west, and inbound filtering. This is just an example of how the certificates work. I will quickly cover it. So inbound traffic coming, you will have a well-known certificate there, right? So this is coming from outside. So you have something like a DGCert certificate or well-known certificate deployed on the Azure Firewall front end. And then you will have that Azure Firewall root certificate or intermediary certificate for the backend in your HTTPS settings. Firewall now knows to decrypt the traffic, and then you already have the certificate on the VM. You should already have the certificate on the VM. So think about this scenario without the firewall. Those certificates should be configured. Then when you put the firewall in, the backend should have the Azure Firewall root or intermediary certificate there. So this is how TLS inspection is configured. It's configured through a policy. You give a key vault where the certificate is, as you see the second field, and then you give a managed identity. So this managed identity will have the access to get the certificate from the key vault for the firewall to do its work. And then the certificate, as you see here, is stored in the key vault. But this is what you configure, enable TLS inspection, and that's all it needs. And as you see here, there's key vault integration, so you don't directly store the certificate on the firewall. Now let's take a look at IDPS, intrusion detection and prevention, the biggest strength of the premium firewall. This is what you need when you want to inspect traffic. IDPS is signature-based detection on Azure. It is continuously updated. So again, from your point of view, just one click, enable it, and it protects against over 60,000 plus rules that are signature-based rules, meaning these are known type of attacks out there that may come to your environment. IDPS will inspect for you, and these rules are over 50 categories, continuously updated. So in the backend, so these rules are managed by firewall, right? It's a managed service. So in the backend, the Azure Firewall knows the type of traffic they see. So they know the new threats that are coming, and they continuously update these signatures. 20 to 40 plus signatures are added every day just to make sure environment is secure. And also because it's managed, because it's continuously updating, it reduces any false positives that you typically see with an IDPS. It works inbound and outbound. It can be deployed in a detection mode and typically that's what you do. So when you enable IDPS, first you put in detection mode. Detection mode it's not dropping any traffic, it's not blocking any traffic, but it is logging the traffic. So now it knows. So now you know what traffic is triggering what signatures. And once you look at it, you check, is this any legitimate traffic that would be blocked by these signatures? Then you look at it, what about it is causing it to block, and you can put exclusions, etc. But you get to tune your signatures accordingly. And then once you know that, okay, now you also get insight into what all is the offending traffic that is coming to your firewall. So once you have that information, you know now you're making sure legitimate traffic is not blocked. You can move it to prevention mode, where you now, if a signature is triggered and that signature is to deny traffic, you can block that traffic. So your backend does not receive that traffic. But that learning part is a little bit important. Just like you do it with any IDPS, run it in detection mode first. Now, if you do have some trusted environments where you don't want to run IDPS inspection on, then there is a bypass list that you can configure and just bypass those IPs from IDPS inspection. And I will talk about the private IP ranges when we look at the portal, but there are rules. Some rules are for inbound traffic, some rules are for outbound, and some for east-west, based on the type of signature we are looking at. And then for that, we need to know what is inbound, right? So any of your private IP ranges, RFC 1918 ranges, are private IP. So private IP to internet is outbound rule, internet to private IP is inbound, and so on. So you can have any type of ranges configured in your VNet though. So to enable you to identify the traffic correctly, you can define what your private IP ranges are. And if you see preview here, those are new features. They are in preview, not production ready until they are GA, but they are available for you to try in your non-prod and understand how they work. So this is typically how it's configured. On the left, you see IDPS, and then on the right, you have the options. If it is disabled, there's no IDPS inspection happening. If you don't want it, just do disable. But you don't want to keep it disabled. You took Azure Premium for this. So you can put it in alert mode, that's the detection mode, or alert and deny, that's the prevention mode. Okay, we have a few minutes, so I'm going to quickly run into, try to finish this. So when you use Azure Firewall Premium, you use an Azure Firewall policy, meaning you create a policy and put all the rules that you wanted in that policy, and then apply that policy to a firewall. There is an ability to have a parent-child hierarchy with these policies, like at an organizational level, these IPs this kind of traffic should be blocked. You can put that in your parent policy. Create a policy with that, and then create a new policy, attach that as that global policy as the parent policy. And as you see here, there's an organization-based policy that will always be applied whenever you have a sales up policy, database policy, and engineering policy configured. The global policy, parent policy always gets executed first. The child policy can only have more stricter rules, not kind of, okay, if parent is denying something, child cannot allow it. And then real quick, a little bit on the priority here too. When you put the rules in a policy, there are rules, there are rule collections that have rules, and then there is rule collection group. So think of rule collection group as your network rules, and then a rule collection group. So when there are large enterprises, you know what I'm talking about. You can group rules based on maybe an organization, based on use case, etc. And underneath a rule collection group, you can have different types of rules. Nobody's preventing that. But always keep in mind network rules get executed before application rules. So rule collection groups also have a priority. As you see here, RCG1 is 100, RCG3 is 200, and RCG2 is 300. But RCG1 does not have network rules. So first it's going to execute RCG3, which is priority 200 because it has network rules. Then any other policies with network rules. So yes, there is RCG2 with priority 300 that has network rules, so that will get executed. No more groups with network rules. So now it's going to look at application rules, and then it will start with the RCG1, which is priority 100. So just wanted to mention it. If you have very, very large environments, you know what I'm talking about with this rule collection groups. And that's why they're important, but definitely the network and application rule priorities come into play. Okay, I think that's all I have. Azure Firewall demo. So we covered Azure Firewall and the SKUs, and let's just look at how it shows up in the portal. There you go. Let me make the font bigger. And let me know if it's still small, I can make some changes. So to configure the Azure Firewall, you go to portal.azure.com, type in firewall and then firewalls. This will bring up a screen when you don't have any firewalls, click create, and I'll just walk through the steps. So the default information, the resource groups, the name, I will just give a name, and the region where you want to deploy it. Azure Firewall can be deployed in multiple zones. If you're familiar with zones, a region has zones. Zones gives you that zonal redundancy within a region. So if one zone is seeing issues like, with power, cooling, etc., and the resources there are not available, you can have your firewall deployed in multiple zones. If zone 1 is down, zone 2 is still running, and the firewall instances in zone 2 will be forwarding the traffic at that point. So there is that zonal redundancy. It is a best practice to build redundancy. Remember the underlying concept, availability and performance of your application. So availability of your environment is important with a central device like a firewall. That's what I make the decisions, right? If the question is when do we, firewall is pretty central. So building that redundancy is a good idea. So I'll just deploy it this way. And then you select your SKU, what we discussed. So based on your SKU, let's go with standard first round. And then there are some differences in how you configure it, also the differences in features that we talked about. But let's look at how it looks from a standard perspective first. We talked about Azure Firewall Policy. That is a construct that is necessary, needed for Firewall Premium. So if I selected Premium here, I don't have a choice. I have to use a policy. But when we came out with standards, if you're familiar with traditional firewall, you go on the firewall and you put the rules in. And that's what a standard firewall enables. The difference between firewall rules and standard is firewall policy can be one set of rules applied to multiple firewalls. Firewall rules, same rules, keep applying to all different rules to keep applying to keep updating different for each firewall. So that's the difference. Firewall policy is a good idea to use. And then you select the policy that you have. And then you choose the virtual network. Let's keep it here for now. Then you choose the virtual network where the firewall will be deployed. I'm just going to give a name. And then I already have a firewall deployed, so it's not liking it. But you give a virtual name, you give the address space for the VNet. What you need to then add is a firewall subnet. So Azure Firewall is deployed in a firewall subnet. Let's create new and VNet demo so you get an idea. It does require Azure Firewall subnet. So firewall is deployed in a specific subnet. This is true for many managed services on Azure. And why do you need this? Because remember, the scale happens under the hood. So it needs those IPs to scale. It needs a subnet to recite those firewalls on. So I can give a range here. This is 10.0.0, then 10.0.254.0. /24. Azure Firewall actually needs a /26, and /26 doesn't need more than that, but you can give a minimum, you need to give a /27. And then Azure Firewall needs a public IP. So demo IP. Now, the important thing to remember about firewall is if you want the traffic from outside to come to the firewall, you need to target it to this I just assumed it is there. You need to target all the traffic to the firewall public IP address. That's why you need at least one public IP. You can have more, up to 250 public IPs, but right now, let's create one. Force tunneling is a configuration I'll highlight here, is when you have a firewall, you have firewalls running in Azure, but you want a centralized place to, for example, on premises to send all the internet bound traffic, or through an NVA for specific checks, etc. Then you can daisy chain these firewalls. This firewall can route traffic to that other firewall to send the traffic out. And that's what force tunneling is. A use case for force tunneling is also where customers request that they don't want public IP. Going back to our main best practices, no public IP, right? But a firewall needs a public IP. But if you don't want traffic to go to the internet through the firewall, in those cases, there is a way to avoid that. So with force tunneling, we have this Azure Firewall subnet. What force tunneling does is on the data plane, there is no public IP. However, these managed services need a public IP for management perspective. So there is a separate subnet that gets created or you create it that is called firewall management subnet. This is where all the management traffic is. So this has to have access to the internet, right? That's how it functions. Does the managed function happen? So you need a management subnet, and this public IP will reside on the management subnet. Then the Azure Firewall subnet that you had, that's where data traffic can go. That's where you can have your default route to somewhere else, to a different firewall. It can be Azure Firewall too, like a centralized place for traffic going to the internet. And then that's how you achieve, or you don't have to send it anywhere. You just, this is for an environment that all traffic stays internal, for example. So that's what this forced tunneling mode is for. And then that's it. Next is tags, and then you review plus create, and your firewall is created. I'm gonna keep it off for now. But let's also X out. I have a firewall created, so we don't need more. So that's how you deploy a firewall. Once deployed, this is how it looks. As I have two firewalls here. I have a firewall standard, and this is how it looks. You know, it's not too many VMs, load balancers, nothing. This is your firewall. I go to the overview page. It gives me the information, what type of SKU this is. So this particular one is a standard SKU firewall. It shows where it is deployed, its public IP, and what is its private IP. So for all communications, you use this private IP. This is from the Azure Firewall subnet. It will have more IPs underneath, but whenever you refer to the firewall, you give this IP shown here. And which VNet it is deployed. And the important thing, provisioning state is succeeded. To see what is the public IP of my firewall, I will go here and check. This is my public IP. So for this particular firewall, so a firewall also has an option of configuring DNS, can be a DNS proxy. So you can configure such that all requests come to the firewall, and then you can have the default DNS or your own DNS configure. You can still say disabled for, this is for enabling. So when you don't have it, it is you don't have the firewall acting as a DNS proxy, so it's disabled, and you just enable it. For rules, so this is where this being a standard firewall, this is the first firewall that came out. We had the ability to add rules on the firewall here directly. So for example, these are the rules I can put in. There is the NAT rules, network rules, application rules. Let's take a look at network rules. So here, and to add a network rule, I will just open this so we get an idea. I can just put a name of network rule 1, and then give it a priority of maybe 200. I also like to kind of use the numbers such that if you want to add rules in front, you have room to add. If I did 100, then if I wanted to deny something before, I cannot. So as a best practice, put it such that there's room to add more rules in the front as you see the traffic. You want to deny some traffic, things like that. Action can be allow or deny. We'll keep it as allow. And then you give a rule name. And then you select the protocol. This is for my TCP traffic. Source IPs, I will say 10.1.1.1.0/24. This is one of my subnet to 10.1.1.2.1.0/24, just as an example. And then I give the port where I want to allow the communication between these two. So as you see here, it's looking similar to the NSGs, but it has, so it is restricting based on source, destination, port, and protocol. Over here as source, I can also give IP group. What IP group does is if I have an environment of a lot of IPs and I want the same rules applied to it, then I will create an IP group and select that IP group here. I do have one. for example, investigate IPs, and then give the destination where all these IPs can go. And also, I could have something like deny this traffic and then add IPs here. Or, I know this is this kind of application, so I can add IPs for that application here, related IPs. So I can do that. So that's based on IP addresses. We talked about service tags, and with Cloud Native, you're able to use that. This would be an example where I would give a service tag of SQL servers, for example, right? And then give the ports that you want to allow accordingly. So this is the benefit, and you can use storage, for example. This is the benefit of using service tags. Now the other, and this is only saying because I have missing information. And next thing is FQDNs. So I can configure my destination as an FQDN, where it is like www.microsoft.com, and then give the ports. So there are a few ways you can configure, and this is the flexibility that Azure Firewall gives you. So you're not just stuck on only IP addresses. But these are the network rules. I have a very simple rule configured for the demo where I am allowing traffic. So I have a hub and spoke environment with IPs of 10.100, 10.101, 10.102/16. So I'm allowing traffic between this environment. That's what I'm doing here. And that's all there is from this point. And then let's look at application rules. Application rules, I'm a bit more specific. I am saying allow Windows update for VMs in 10.102, because now if I'm expecting Windows VMs here, I will just use the FQDN tag and allow Windows update. But I'm also adding a rule that from source of 102, so the spoke to VNet, which is 102, we'll take a look at that. I'm allowing specific traffic to Microsoft.com. That's what I'm doing. I want to go back to network rules because I did have another rule there. I also have, oh no, not that. I also have an FQDN rule where I'm saying from 10.101, allow to www.bing.com. So I can have FQDN level filtering, and I can have application level filtering. That's what we want to do. Now let me take a look at the virtual networks that we have. So I have a virtual network VNet standard. And the firewall that we were looking at is actually deployed in VNet standard. So this is my hub environment. So this is where my firewall is. And then this firewall is paired to two spoke VNets. VNet standard spoke 1 and VNet standard spoke 2. And you see the status is connected. So this hub connects to two peers. And I have a VM in each. So let me just go to the VM. So this VM has an IP of 10.101.4. So 10.101 is my spoke 1, 10.102 is my spoke 2. So this resides in spoke 1. And then I have a VM here, which is in spoke 2. 10.102.1.4. So let me access this VM and then see. So let's load this, and let's load on both VMs. It times out, sorry about that. Had it loaded and ready, but there you go. So now if you remember 10.102, I could access Microsoft.com. you see here, this page loads. But I did not put anything else for 10.102. So there are some other URLs that I want to go to, like I want to do search. Oh, let's put it in right. And as you see here, this action is denied. I cannot go there because there was no rule matched. So this gives me insight. Am I supposed to access this site? If yes, then I need to go and add that rule. So what also happened is there is a default deny. So I was not able to access this because there was a default deny. But if you remember the rules, we had allowed in the network rules access to spoke 1 VM to access Bing. Then this should work here. So the page loads. And that's where the rules combine. So if I forgot and I had just for this demo separated out, 102 can go out to Microsoft and 101 can go out to Bing. But that's how the network rules work. So we had a question before on spoke to Hub from Amar, I believe. So let's see how this happened, right? So we saw that these VNets appeared to each other, but spoke 1 is peered to Hub, spoke 2 is peered to Hub, spoke 1 and spoke 2 cannot talk to each other. So can I talk? Actually, let's check that. So I can actually reach 102. And if I look at my config here, this VM is 10.101.1.4, and it was able to reach 10.102.1.4. But spoke 1 and spoke 2 are not directly peered. So what needs to happen to make this connectivity come about, right? So for that, if first thing is we saw how NSGs work, right? So each of this VNet will have a subnet, and on those subnets, I have to allow traffic. So I have put a broad rule that should allow from source 10.8 to source 10.8, allow any port protocol. This is broad in production. Keep it tight, but I could have said 10.101 to 10.102. Allow traffic. So now this VM can go out and talk to 10.102. If I want return traffic, I put 10.102. So at an NSG level, I have allowed communication between these two spokes, right? But they are not connected. So for that, I need to add a route. So I go to route tables, and I go to routes and add a route here. So here I have a default route for everything. Go to the next hop of the firewall IP. This is the firewall IP that we saw. And the next hop can be many things. If you're using VPN express route gateway, then it is virtual network gateway. Next hop could be internet if it's an unknown, but I want a hop in between. And I do need a hop in between because they are not directly peered. So for firewall, you choose virtual appliance and then give the firewall IP. It still is like a virtual appliance, so then give the firewall IP. So after we add these routes, again, routes need to be attached to a subnet. So I come here and I attached it to this VNet spoke to subnet. So I go give the VNet subnet and then attach which route table I want to use. So if you see, look at this subnet, it has the NSG applied and the route table applied. And similarly, I attached it to, the default is actually the spoke 1 subnet. So that's how I've attached it here as well. So once you have these routes in place, the traffic goes through the firewall. Yes, if I do trace route 10.102.1.4, this should go through the firewall. Oh, I don't have it. Anyways, this will go as the next hop through the firewall, and that's how it'll reach the spoke to VNet. And so that was how a firewall standard looked like. Let me go back there. I want to take a look at it. So here as we saw, we added rules and at this firewall level. So if I have another firewall, I'll go ahead and add all of these rules there. And this is demo. There will be a very long list of rules. Then in another firewall that I deploy, I will add rules there. And now if as our number of firewalls grow, you know the amount of work that goes in. And as always, we want to make it easy to manage and operate. So even for standard firewall, you can apply firewall policy. So there it tells you create Azure Firewall policy. So if I had a policy, I could have attached that here as well. So for that, first let's look at how let me see if I have Azure Firewall Manager open. No, I don't. Or maybe I do. No. So let's look at Azure Firewall Manager first. Oh, there it is. Azure Firewall Manager. So we talked about how Azure Firewall Manager is a single pane of glass. So let's see how it looks from the Azure Firewall Manager perspective. So you go again to Firewall Manager, put it in search, come here. And the first option I see on the left side is virtual networks. This lists all my virtual networks here. And I don't see all of them, but I see, okay, so this lists all my virtual networks here. At a first glance, it tells me which firewalls, what all are my virtual networks, which virtual networks are protected and which are not. So I have some virtual networks that don't have a firewall. And then I have some virtual networks that that appear to a hub which has a firewall, right? And then as you see here, this firewall, this VNet has a firewall policy attached to it. And then this VNet has a firewall, but it is managed by rules. So this is how it will show up. I can at any time change this to have a firewall policy, so I can update that. But this gives you, so I can see all of these VNets are peered, so they are protected by a firewall as well. Now, if you have virtual hub environment, you can add a firewall here. I have not created a virtual hub, but I think I saw a question in chat. Can I have virtual networks and hubs have the same firewall? So the way virtual hub works is it is a managed VNet, the hub, and then you can connect spokes to this as well. If you have spokes connected, they will use the firewall in the hub, just like in a traditional hub and spoke environment. But if you have a hub and spoke separate, if you have not peered that to the virtual hub, the managed hub, then you need a separate environment, right? So if they are separate environments, you need a separate firewall. But virtual hub is actually a managed hub. And then if you have VNets connected to it, they are spokes. You can route traffic through the firewall then. So let's look at Azure Firewall policy. Here I have one policy. So it will tell me all the policies that are created. And it will tell me the association, where it is associated. And then you go to virtual networks and see the name of the VNet that it was associated to. So I'm going to go into this policy now. And really quick look at the rule collections. So we talked about rule collection group, right? So this is a rule collection group, for example. If I can make it big, and let me know if the font is good to read as well. So here I have a rule collection group named default network rule collection. As you see, anything default, you don't have to have created a rule. If you add a rule, there will be a drop down where you can select where it will show the default rule collection group. And if you don't select, it's going to put it in one. But you can also add custom ones like I did here, and then you can add rules to it. I want to be able to see this. So let's take a look at some of the rules. So DNAT, remember anything that's behind the firewall, if the internet wants to access it, it needs to route through the firewall. So for that, you need to put a destination NAT address. And this is how a destination NAT rule would look like. So I give the name. In this case, I want to RDP into a VM, let's say from my laptop, and then I give the source IP. Actually, my IP changed today, so I just made it star. But very, very specific IPs here if you put it here. Now we do have Azure Bastion host. So if it is for management like RDP and SSH, you don't need to use the firewall. Azure Bastion is actually a managed service. It's like a jump box. Ideally, you want a jump box, all the connections come through that, but now you have to manage the jump box, update from, to keep it safe from threats and scale, etc. So Azure Bastion does all that for you. So if you use Azure Bastion from the portal, we can connect to the VM. The VM only needs a private IP. Azure Bastion knows to connect to it, and it'll take care of the connection without a public IP. But here, just for demonstrations, I added this RDP, then I give the destination IP, and this would need a public IP for the, actually, this would be the public IP of the firewall. So this IP will be of the firewall, and then the destination port that you want to connect to. Now the firewall will now translate this IP to the actual server, which will be the private IP. So we still keep the VM as private, but you have to route all the traffic to the firewall IP. And then that's it. Then you give the translated port as well, and you are able to RDP. And I will show that in a bit. But now let's look at the network rules. So similarly here, let's add a rule collection. The view is a little bit different, but the network rules look the same. So you give here the name 1, and then you give the priority, and then you give the action for this rule collection. So all related allow connections can come here. But like, see, there are rules. They are all in rule collection, and the rule collection group. So at a rule collection level is allow, and you can give 1 rule per rule collection also. But if I see here, there are these 3 options that I can choose from by default if I didn't configure this. So I'm putting a network rule. So one way to group this is all network rules, all application rules, all NAT rules. And that's what we will do. So in the rules here, I can give the source, protocol, destination, port destination, and destination IP, right? So it's that simple, but destination type again can be IP service tag, IP group. So that's it. So what I'm doing here is VNets can access anywhere. Oh, sorry, VNets can access VNets on any port, so internal communication is okay. Outbound, I have one specific IP that I'm given. So at network rule level, I'm not allowing anything else. But here I have app rules that say from 10.0.0, so from my internal network, I can do Windows Update, but here is a new feature. This is a feature for firewall policies where how do I access this? Where I give the destination type of web categories. The beauty of web categories, I think I didn't cover in the presentation, is in Firewall Premium, you can define web categories where you say, allow traffic to all the news sites, right? So instead of giving bing.com/news like CNN, CNBC, and multiple sites, I just allow a category. So here I have selected search engines. I should be able to search, like I allow employees to search. And then I have selected news. Now I lost it. But see, all these categories are also broken up. All these categories are also broken up by broader categories of productivity, liability, business, and so on. So I select what can be allowed on through the firewall in the environment, and then these are broad categories, bunch of rules. You get to just select one. So I have allowed news, and I have allowed search engine, but that's all that's allowed on this firewall. So let's take a look at how that works first, and then we come back to this. So I had a connection to RDP, and this is what I did. I have a, give me a second, I have to share the right screen. So I have an RDP connection to the host that we saw. So for that, to do RDP, I give the public IP of the firewall because this is a laptop on the internet, not in Azure. So it's not my internal environment. So I give the public IP of the firewall, and here it loads. It's too small, I know. Here it loads the page for me, right? And I can see, I already had this, but if you remember, I have allowed search sites. So Bing.com would be allowed, and I should successfully load this new page. Similarly, okay, so this is my search. So let's try something else. I'll just do CNBC. So just for the fun of it, this should load, right? But now, let's say I try LinkedIn.com, and you see that I cannot load this page. So then what happened? If you remember, we allowed search sites. So Bing.com, other search sites are allowed, but all the other categories are not allowed. Now I can go here and add a particular site, but I can also check which category this falls under, right? Because I am not sure where LinkedIn goes. Is it social networking? What is it? But this is a very cool link where it will tell you this link, which category it falls under. So this is professional networking. I will look for that category, and I have a choice to allow the entire category, or I can put a specific rule for LinkedIn. Now, if you want to allow the whole category but block some particular URLs from here, you can do a category search. You don't want this URL, you put a deny rule above it, and then allow the category if you need to allow the category, and that's how you take care of it. Okay, so that was web categories. I want to look at threat intelligence. So we talked about it. Threat intelligence really provides intelligence from Microsoft Threat Intelligence feed and identifies known malicious IPs and FQDNs and can block it. So to configure it, I have three options: alert only or alert and deny. So when I do alert and deny, the traffic is blocked. If I don't want to block, then alert. But I mean, typically threat intelligence, you want to deny it. Now you can have an allow list. So if there was an IP for your environment, you want to test some traffic or send some traffic, then you can add allow list here and you can allow those IPs. Similarly for FQDN. But the beauty is this single click. This single click and my environment is protected from all those malicious traffic. Very, very easy. I like threat intelligence because nothing else to do here. Just it's already known to be malicious, right? So it's very easy to enable it and be done with it. Now let's look at, so TLS inspection I walked through. I'm going to do a demo of IDPS. So let's look at IDPS. So we talked about two modes: detection, prevention. Again, alert is detection. This is where you start. And then when you want to put it in prevention mode, you go into alert and deny. Again, this is the biggest benefit of Premium in my view, because IDPS, again, identifies known signatures. So we have 58,000 plus rules, known signatures out there, and protects your, and this is where the firewall functions comes into play and protects your environment from all of those signatures, and you'll be surprised once you put it in how much of such traffic you receive. Whenever you had a public IP, that traffic comes to that public IP. So how does it look after I enable it, right? So this is the list of signatures that are there, that are configured, and I have 3,423 pages of it. So these are the signatures. As you see here, there is a signature ID. There is a mode, alert mode, and alert and deny. So as you see here, some signatures may be in alert, some in alert and deny. They do have a severity and a direction. We talked about the direction, inbound, outbound, or bidirectional. And then it gives more information with description and what kind of traffic this is. So when you get an alert, whenever a signature is triggered, the logs, you have to enable logs. The logs will give this information of the ID as well as the action that is taken, as well as source and destination. So that's how you know if you're getting a lot of alerts and denies on a particular signature, but it's catching the legitimate traffic. You come here and either turn on, turn off, or bypass it. You do have that option. So here is where you come and update your private IP ranges. So if my VNet is running like public IP ranges as private, you can update the IP addresses here. And then this is the bypass list. You need to give source IP, port protocol, and destination. So it's simple. You just say these IPs bypass IDPS. So a good reason is, one is a lot of false positives, but also to a particular application, but also, you feel like this environment is trusted. Just keep in mind the main principles: never trust, but there you have your environment, you know what to do. If you did need to bypass something, you have that option. So now let's take a look at some of the logs. So let me come back here. So one of the things you have to do on Azure is, I need to go to the firewall. And that's why I'm here. So one of the things you have to do on a firewall is on any service, actually, you have to enable logging. Metrics will always be there by default. You can chart it, but diagnostic settings you have to set, and this is where you say you want to send your logs, capture logs on it. And capturing log is very important. Just putting these protections in place is not enough. You need to gain intelligence, understand what's happening, to allow the traffic you want, but also to know what threats you are seeing in your environment and plan accordingly. So these are the different types of logs that are captured. I typically do all, but what you want to capture and monitor, so IDPS, network, application, DNS, and NAT rules are some things that are very common. And then you send it to Log Analytics workspace. Your destination can be diagnostic or resource specific. Resource specific is just more readable logs, so a little more information on it, and you can, it doesn't have, but usually it'll have information on it. So you do have those options. It's just more readable logs. So you have to enable this for all the services that we'll talk about today. It's actually, these are the very critical services. So you have to allow those logs, and that's how you'll be able to troubleshoot and monitor your environment. So now once you've allowed it, I had a diagnostic rule in place. Now once you allow it, come to logs, and there are some queries that you can run. I did not do that. So for example, we did not do the demo piece. So let me switch to that for a bit. Well, we did the demo for the rules, but not for IDPS. So let's open this and let's see if I can do a call from here. Yeah, I can. So curlbing.com, we saw this as accessible, right? But if I had malicious intent, and then I will put some user agent that I shouldn't, and then say, oh, let's see, Laxin. It's not going anywhere, right? Seemingly, it triggered a signature where it is going to deny it. After some time, it will actually throw an error message that this is not allowed. So that's something that was IDPS in action, that you cannot have sub-user agents in your request, right? So, so that's the protection you get. Now, here is one of the logs I've run. So when you come to log analytics, this is where you put your queries. And all of these are one documented, but if you come here, there is a place to find queries. So they're also documented. You can just come and copy these. That's what I did. And then you just run the query. Let me try to run it one more time. But before I run, sometimes it takes a minute. I want to look at how the fields look like. So for example, here I ran this a couple of days ago. The message says HTTP request from one source to a URL. And as I see, it ends in opinsights.azure.com. The action is deny because there was no rule matched to allow this traffic, right? So proceeding with default action tells you why it is denied. If you had a rule, it'll say blocked. But now based on this, I will say maybe opinsights.azure.com is something I need to allow. So it gives me that visibility and insights and can allow, or I will know what kind of threat I am seeing in my environment. So that's the level of details. Like you can see the source IP, the FQDN, the target port, and the reason why it is blocked. I'll just run this and see, but these were not the logs that I was even expecting. So you can see, oh, I don't know what's going on. Let's remove it. Let's keep this last 7 days. And run. I am having some difficulty, and that's why I had the logs log run saved, so I don't run into issues. But we saw the logs, and there are more ways to see the logs. Just also keeping the time in mind. So now we talked about Firewall Workbook. So this Firewall Workbook is also available through Azure Sentinel. So if I go to Azure Sentinel, and I can walk through those steps in a bit, but you can see the same Firewall Workbook there. Let me just walk through this and we'll go there. So at a high level, you can see the Azure Firewall overview and then drill down into specific types of logs. So as I see here, it gives me information like a dashboard, like a chart. So this is more like metrics information. Events that occurred by time, I can see for over a time range, what is the amount of throughput that I'm seeing, right? So it's going up about around 15K, but I'm also seeing the traffic is increasing. So it gives me the pattern. And if there is a super sudden spike, you know what to look for example, here. And then it gives events by firewall. I have multiple firewalls. So this is color coded for different firewalls. Events by category, if I hover over it. So I have it too zoomed in. So if I come in a little bit, I can see the more details here, what type of logs, so application firewall, which firewall, DNS network rules, etc. And then you can see the throughput. That's something they are important in. And SNAT port utilization, that tells you if you are kind of reaching if you have so many IPs, if you're having more traffic than the ports can handle, so you put in more IPs. And network, just rule count, network and application rule hit counts, right? So this is just at a graph level. Any abnormalities you can check quickly, and that's the purpose of it. So you build a dashboard. This is what a dashboard would look like. And then you go into specific rules for this. So as you see here, I have filters by unique source IP addresses. So 10114 is the top talker for me, 93,000 packets, and then the rest of them, and it gives the information. This is a demo environment, and yet I'm seeing so much traffic. And then which application rules are mostly used, right? So that gives me an idea what kind of traffic I'm seeing and if my rules need to be tweaked. And then it also gives a last log. When was the last time this kind of rule came in? And then denied FQDNs and what were these FQDNs more importantly. So it gives you the FQDNs that are being blocked and you get an idea of where the traffic is coming from and you can tweak your rules accordingly. Similarly allowed. Each of these has a graph. What traffic is coming by geolocation, as long as I have customers in US and I'm expecting US, this looks good, but I have some traffic coming from Europe. Then I want to look into what is that traffic, right? And then I want to identify who is coming from there. So that's the visibility it gives. Rules by action, like DNAT rules, so many denied. So denied is what I would be interested in and click on that. So this is network rule logs. And then if I click on any of this, the rest of it will change. But let me just go through these real quick. And then this is what I would be interested in, right? That everybody would be interested in. What are the, when I deny traffic, what are the IP addresses that are denied? So if I have a source IP, this is demo. We have done this on purpose, but this is a VM that shouldn't be going, that is denied some traffic. So I want to look into it. This also gives a good indication of, is there a compromise, right? If it's just going to malicious side, is there a compromise? And then it also gives a high level view of which ports are seeing the most traffic. So for example, 3389 is seeing a lot of traffic, but clearly, because this is what happens, RDP is open on the public IP, public internet, and it's not just my IP anymore. I'm seeing a lot of IPs trying to access my server, as you see. And that's the protection again, and that's why I know public IP. Okay. You do have logs here. You can filter on that. And so for example, it gives the information on the network. It also gives the information on the continent. And let me see if I can filter on traffic that came from Europe. And yeah, so now just by adding the keyword here, I was able to filter out the traffic. Now I know where it is coming from and the source and destination IP. So this is traffic going out, and I want to know where it is going. So this is a good example of I am not expecting this. Let's drill down into 10114. So I'm going to look at IDPS logs real quick. IDPS action counts, how many alerts, how many drops. Protocols, what protocols are mostly seen? And this is actually a real life also. This is test, but in real life, TCP attacks are the most common attacks, right? So you will see TCP always more, but just keep that in mind. I will give all the types of traffic that you're seeing. And then here's the important information. So what are the top signatures that are getting hit? So I see many here. I have to, so when I have this information, I can copy this ID and go back into my VM and search for it, right? Sorry, not VM, on my firewall, and go to that IDPS signature. Let's do it. So I will go to IDPS signature page on my policies, and then go to signature rule, and then add this. And here I see the signature. This is for outbound. It's going to be alert, and it gives me RDP connection confirmed. So RDP connection is allowed. It's seeing a lot of traffic, and it alerted me. So I'm going to block, but it is alerting me. Similarly, let's go down. So I think the important thing is what signatures are being captured, what source IPs are triggering it, and what is the volume. That's important to me. Example, I know one signature that we tested here, so I'm going to look for that over here. But before we do that, this gives a graph of IDPS. So usually it was quiet, but suddenly there is a spike, right? So something happened to see this traffic right now. And I'm also seeing traffic from multiple places. See here, this RDP is to my VM. I am only expecting from my IP, but I have 150 IPs in United States that are trying to access it. This is the threat landscape out there. So when you put a public IP, know that once there's a public IP, it's trying to be reached. And I'm seeing from Korea, China, Russia, Germany, which I have nothing running in each of these regions and nobody there trying to access my VM. So user agents, right? So now let's try to look at what kind of traffic is there. Actually, we ran one, but see how many of these come up here. So user agent Black Sun, and this comes. So this seems like this is legitimate. Now this is the signature I wanted to copy. And then I can see when this happened. Actually, so this is not refreshed. I have to refresh, but this is something that happened on 3/13, and it'll give me the IPs from where it originated. And that's what is important to see. If I were to, no, that's all. So if I were to go to investigation, it gives me more information. So I want to look at the denies, but look over here. It gives me my VMs and the information on these VMs. So these are the top VMs it is seeing the traffic from, and it is giving information here. Any denies. So here, for example, am I supposed to allow this traffic, right? So it gives you that kind of information. If you see a large number, you know to take action. And then these are the logs. So let me see what kind of logs are here. So you see the source IP, source port, destination again, and this is deny action. There may be allowed to, but I am interested in deny right now. And then go down, and I want to see. So this is threat intelligence. And here is where you see more information on the threats that your environment is seeing. When it is alert, you want to go and investigate. But I could use the search feature here too. I don't know if this will come up because I did not refresh, but see the Bing searches that I did are coming up here, and so on. And then 3:15, that's from today, so that got captured. And this is what we ran today. Similarly, let me see if Black Sun is being captured. Not yet. And that's how you filter, though. You know, that's what you filter on, and it gives you information. I will go to the policy, and then this is the one I want to show you where a user agent it is a network Trojan was detected and it's blocking based on this signature. This is alert and deny. Now there'll be more user agents, so you may want to just change it to alert and so on. I think that's okay. Let me show Sentinel real quick, and then that's it. So Sentinel is Azure's cloud native CM. If you're familiar with CM and Source, if you're familiar with these solutions, they are like one place to send all the logs. And as you see here, I'm selecting my log analytics workspace. So you send all the logs to log analytics workspace to be able to integrate with CM because Sentinel builds on top of that log analytics workspace. So for here, I can connect my Azure Firewall and other Azure services. By the way, we have sessions on Sentinel, so I'm not going to go deep here, but you can have your different NVAs connected here too. You can send all your logs for Azure services, it will be there, but also for other logs. So when you come here the first time, this will not be connected status. So there will be permissions that you need to allow, and there is that diagnostic logging that you need to allow that we saw. And it needs to be in log analytics for Sentinel to see for these Azure services. And then once you are connected and you start seeing the logs, once you did the diagnostics and you start seeing the logs, it will show the status of connected. As you see here, there are workbooks, and I will open that workbook, but I can also access the same workbook from here. So here I have Azure Firewall, and I access this workbook from here. So this is the same workbook we were seeing. What I want to show is that it is an interactive dashboard. So while we saw all this information, you can change it to see only what you want. You can add, edit any section to add what more information you want to see. So that's what an interactive dashboard is, and that's what it enables. So there's this new feature of Content Hub. If you go there, you can see the different solutions that are built, and there should be a solution for Azure Firewall as well. And if I go to manage. So this is where you come to enable it, and you see all the different types of analytics rules that are built for the firewall, what a firewall will typically do. And you can select and enable these, and then for each of them, you can configure actions, responses like we talked about. And then there are these hunting queries. So these are built specifically for your Azure Firewall. If you're using Sentinel heavily, enable this, and this is like the automated additional protection for your environment.